Bonjour la France. Bonjour les scalanistes. Alright, so today I figured I'd show you something that isn't Scala. You might not like it. I've had my ups and downs with this language. Actually, JavaScript, if you've encountered it, I'm sure that you hate it as much as I do. I don't think that some people really, really love it for some reason I would never be able to understand, and then most other people hate it. There's no middle ground there. Actually, it's so bad that Brendan Knight, its author, has essentially spent his career since creating JavaScript apologizing for it. So I have like a bullet list of things that are wrong with JavaScript. It's a mess. And there's no other way of summing it up really. So a lot of people have been experimenting with alternative languages that simply just compile to JS. So you still have the awfulness of like the ecosystem, but at least you don't have to write that particular nasty language. And sorry, I totally rewrote my slides. I'm just going to. So I've been through quite a few of these alternative JavaScripts. You have things like CoffeeScript. CoffeeScript is essentially you take JavaScript semantics and you take Ruby syntax and you squish them together into a language that is both and neither in a way that is not really that much better, but awful, to be honest. You've got TypeScript. That's what I've been using up until the point that I discovered the language that will be the topic of my talk. TypeScript is an attempt to take JavaScript and add a type system on top of it, a gradual type system. And I think my major problem with JavaScript is not like it looks ugly or has peculiar semantic flaws, but it's untyped, and it's untyped in a rather poorly designed way. So whenever you write software in JavaScript that tends to grow a little beyond a couple of hundred lines, it gets a little unwieldy. And add a type system, I figured, and this will be, the pain at this point will be alleviated a little bit at least. And it did. But TypeScript is sort of, the type system is reminiscent of C#, perhaps. It's a bit more powerful than that, but it leaves a lot to be desired. Essentially, using it, I kept asking myself, why can't you be Haskell? Because once you've gotten Haskell, you can never really properly go back and appreciate another language. And trying to do fancy stuff in TypeScript's type system doesn't normally go that well. I actually ran into several instances where the complexity of trying to type check my programs went towards infinity and probably would have taken a couple of billion years. And yeah, in Haskell you can just write your types, write your code, compile, and you're done. So it was with some excitement that I noticed the arrival of Purescript, which, while it's not the first attempt by far to build a language like Haskell that compiles down to JavaScript, it's, well, actually it's not also the first that has been designed specifically for JavaScript, but it's I mean, there was Roy. I think Brian McKenna got bored with Roy. At least it's not currently being developed. Like Brian came to Purescript, and you got these things like GHC.js and other things that essentially try and take Haskell and compile it to JavaScript, like Haskell verbatim. Problem there is that Haskell has its own platform, and JavaScript has something else that I'm reluctant to dignify by calling it a platform. And so what Purescript is trying to do is take those essential semantics of the platform that it has to run on and design a nice, clean language around that. Language that happens to look so much like Haskell that essentially, if you got a Haskell mode in your editor, that will work fine for Purescript as well. It's created originally by this guy called Phil Freeman, and I couldn't find a high-resolution photo of Phil, so I just googled Phil Freeman cosplayer, and I found, I think somebody's trying to look like him there. I don't know. Anyway, Purescript. I mentioned it's got a very Haskell syntax. That is, well, if you like Haskell, that is certainly a selling point. But more importantly, it's designed very specifically to not only live on the JavaScript platform and integrate semantically, but it also compiles to very concise and never mind. Let's try that again. Where was that? Yes. It compiles to very concise JavaScript, very readable JavaScript. And it's very close to the source language, even though the languages have quite a few different concepts. It's actually a pure functional language, which is important when you try to reason about it, of course. Like Haskell. To get around having to actually deal with the outside world now, well, Haskell goes with the IO monad, everybody's favorite monad. Purescript has this thing called extensible effects, which I think Oleg invented them, so they must be cool. And essentially, there is an effect monad, which sort of looks like the IO monad in practice, but it's more extensible. And it's got a foreign function interface to talk to JavaScript. So essentially, what your Purescript code ends up looking like is whenever you are doing something that isn't pure, whenever you use side effects, you will most likely be using the foreign function interface, writing JavaScript in line in your Purescript and wrapping it all in an effects monad to say, this is side effected dangerous stuff. So I could keep talking about why Purescript is so amazing, but I figured it would be a lot better if I just showed you. So I'm gonna let's try and bring the mic back onto the mic stand. Should we mute it while I do this? Is this gonna work? Can I switch it off? Alright. I'm gonna try live coding with this mic in my face and let's see how that goes. Can you still hear me? I'm a bit further from the mic. Yep. Technical issues. Somebody forgot to bring the headset mics. Alright. So this is what Purescript looks like. It looks deceptively like Haskell. I've got some code here. Compile. So far, it compiles. I thought I'd show you just the basics. I'm going to try and make a list data structure, a simple single linked list. So I'm going to mostly do that the same way I did in Haskell. You declare a data type called list, and it is a list of type A, which is a polymorphic type variable, which means you can be a list of anything, but it's got to be the same type, of course, throughout. So to construct it, I can go cons A and list of A, which means essentially take a value and add it onto the list. Or I can have an empty list, which I've called it. So see if that compiles. So far, so good. You can actually use it. Then there's no instance found or prelude or show. Because Purescript, like Haskell, has type classes, and in order to be able to print a value in Purescript, you need to provide an implementation for the show type class. I can remember which key uncomments and not delete the whole thing. There we go. Second attempt. So probably still can't print it, no, because it's going to provide the type. It's the number. Yeah, no, it's. So the thing is, it doesn't know what the type variable A is when I just say nil, because it doesn't have a value of type A, so I can't compare it. So I needed to provide a type in this case, but I can go cons1 onto nil, and that gets us a list of length 1 and nil. And I can go on. Let's create a list of 1 and 2. That's 1, 2, and nil. That's very exciting. Now let's actually try and do something useful with this. I mean, you can also be a functor when you're on a list. It's sort of embarrassing if you can't be a functor. And to be a functor, that implies that you need a map function. So let's try and implement one. So for all types of A and B, let's take our function from A to B, and a list of A, and what should that function return? B. So essentially, this is a function that will take this function from A to B and map it over all elements in list of A. And to express that, you'll notice that Purescript has a pattern actually, just almost exactly like Haskell's. So if there's an empty list, and we map the function f over the empty list, we get the empty list. And if we have a function f and a cons of x and more x's, that's going to mean that x is the header and x is the tail. That gives us cons of function of A and map function of A, sorry, x. Indeed. My notes are written in Lisp style. Of course, x and x is very confusing to a Lisper. It's explanation to Haskell, but of course, makes a lot more sense to a Lisper if you go car and cutter, which is a more understandable. Let's try that. See, suddenly it's more readable. So let's see if that actually works. Does it compile? Oh, right, yeah. This is a bug I've completely got to fix. Because if I wait too long, it's going to compile it. My connection to the record times out. What I'm going to do is I'm going to copy this buffer into my clipboard. I'm going to hit refresh, and hopefully I still have my code when I'm done. So I'm trying to remember to compile more frequently. See how it works. Okay, so I had a list, cons1, cons2, nil. That still works. Now let's map. Should have been just go partially apply plus 1. So this gets us a function that adds, because Purescript is currently like Haskell. The plus operator, of course, takes two number values. And if I only provide 1, that means we get a function that will take 1 and add it to whatever you call it with. So this should get us, just add more parentheses, people want to know what's on this part. This should get us a list of 2, 3, and yes. Cool. We just created a functor. So to celebrate, I'm going to implement the functor type class. Because that is functor list of type functor list. can't just call things map, because that's going to make it readable to ordinary users. So in Haskell, the map is called less than, dollar, greater than. You don't follow that, they probably think you're stupid. But that's Haskell for me. And the implementation for that is map. So now instead of going map on this, should be able to, sorry, I didn't implement it as an interface, did I? I might have to go parentheses, less than, dollar, greater than, close parentheses, just to make this fantastically readable. It's starting to look like closure actually at this point. And it still works. Great, so now we're creating a function. Do you know what that means? That means we're doing category theory. Category theory is awesome because it makes you feel smart. It makes you feel like lots of people are stupid. Except for us commands to be smarter than you. So this is the point where I probably start talking about monads, where I'm containing myself. I'm going to try and look at some slightly easier parts of category theory instead. Semigroups. I like semigroups. Semigroups are very easy to understand. Essentially, a semigroup is something that fulfills the associative property, which means if you got A plus B and you add C to A plus B, it should equal what you get if you take A and add it to B plus C. So essentially you have an associated binary operator, in this case I call it plus, and you have a value. And if you can use the associated binary operator, precise language is important here, on the values in this fashion, you have a semigroup, essentially. So there's also the monoid. Once you drop the semigroup, the monoid comes easily because it's just a semigroup, except that it has an empty value as well. It has an idea of an empty value. So if you got the empty value and you take the value A and you add them together, if you get A, then you have a monoid. So let us try and then some. I'm going to go with the simplification instead. I just want to specify too much. So I've been writing a game engine essentially in Purescript, and a data type that comes up a lot is a coordinate pair, or essentially a pair of numbers that can represent a point or a size or anything. So let's make a diagram for it. So a pair has a constructor called pair that takes two numbers. And I believe I got the implications for equality and shown and some other things that I'm getting to. Let's see if we can make it fine. Yes. So I can go like pair 1, 2. That gives me a coordinate of point 1 and 2. And so does this fulfill the associative property? What do you think? Yes, is the answer. I mean, if one number does, then obviously because 1 plus 2 and yeah, inserts into the root that I showed you earlier. Because one number does, then most likely two numbers do as well. So let me, this one's dropping. Let me implement a function add pairs, which takes two pairs and returns a new pair. Let me compile just so we don't type maps. So for a pair x1, y1 and a pair of x2 and y2, we get a pair of, what do you think? x1 plus x2 and y1 plus y2. And essentially this should, let's try it. Pair 1, 2, pair 3, 4. And that's a pair of 4 and 6. That looks legit. So this gives us a semigroup, doesn't it? Let's actually make that formal. Let us implement a semigroup instance. You might note, if you know Haskell, that in Purescript, type class instances have names. There's potentially Purescript avoids some of the funny things about Haskell type classes, but I said potentially, it hasn't been implemented yet. If they designed it that way, I don't know. Anyway, I said the group would have, well. And of course, plus will be too easy. The associative operator in Purescript, as in Haskell, is less than greater than. And our implementation is like that. So, take this one. Pair 1 and 2. Less than greater than diamond, let's put diamond. Pair 3 and 4. Get us 4 and 6. Just by providing an implementation for this one, for the semigroup. And yeah, that's not fantastically exciting, is it? But what is exciting, assuming I can get this to work, is that we have something called quick check in Purescript as well as in Haskell. Quick check essentially is generated testing, but very broadly. It allows you to test functions by auto-generating tests for them. Essentially, if you've got a function that takes, say, 2 numbers, quick check will generate test input that are random numbers just by looking at the type signature. It's all very magical and some very wonderful. And it works amazingly well. Let us try. The thing here is I wanted to test whether this actually is a semigroup. I wanted to have a formalized way of testing, of proving that I have a semigroup by creating this data type and this associated function. And so I wrote a function for that, which is very long-winded, so I won't show it to you. But let's see if we can get the type of it at least. I believe it's been imported. I think I'm going to have to test, check properties, and then we can go get me the type of verify semigroup. There it is. So this is my function for testing whether a value and whether a value that has a semigroup implementation is actually working like a semigroup. So it takes, as you can see, 3 values of type A. That's going to be our A, B, and C, essentially. And it returns a quick check result, which tests whether or not the test passed. And the type A has to implement semigroups, has to implement equality, so we can test that this is actually working, and it has to implement show, so we can actually print the results. So let us try and provide implementation. Let's write a test, essentially. I'm sorry, I got some. I can try and scroll this up for you in the back, but when I try and move the cursor back up, it just, because of the low resolution thing doesn't work in the editor, it just scrolls back down. So I'm sorry, you're going to have to clean your hands a bit. So I'm going to write a test. That is semigroup. It takes 3 pairs and returns the result. And the implementation for that, quite simply, is my function verify semigroup. Because this is polymorphic. It only requires a semigroup thing. But I've made an explicit implementation of this called pairs. And if you notice above, there's an instance of arbitrary of the pair, which is how I tell quick check how to generate random values of the pair. So now I can actually quick check it. Oh, sorry. I forgot. Quick joke, Pure has a weird syntax. It takes a random seed, and it takes the number of tests around. Let's go with 100. Then it takes the test. So this runs 100 tests, and it looks like it's succeeding. Let's try and put that on the screen. Yeah? Should we try and make a rating test? Let's mess this up. Let's go like multiply by 1, like opposite. We run the test, we get failures. And this is why I didn't want to show you the function, because it's mostly just how to print all this when it fails. You can see it's generating random values. And you can see that it's trying to verify that essentially these two should be equal. And they're not. So yeah, that is not a semi-group. Anyway, I'm going to fix it again. I'm going to this was the slide that I was supposed to be moving that on, but never mind. So let's get to the interesting part. Actually got 13 minutes left, so actual chances of getting to this game I thought I read for you. Because why not? I've been using Purescript to write a game management session, and I thought I'd show you how easy it is to build a game. I've got 18 minutes now to do it, and see how far we can get. It should be straightforward. So the idea is I've got a type here, which represents all my game objects. They are going to have an ID. They might have a CSS class. And they've got coordinates on screen. They've got base coordinates so that I can essentially apply X and Y as an offset so I can control where the origin of the coordinate system is essentially. And it's got a velocity, both in the X and the Y axis. So that's all I need to represent an object on the screen. I got this function here that I'm just going to use later to check if two objects have collided. It's not accurate, but it works. And then here's, oh yeah, God, I need to fix this bug in the editor. So this is an example of the FFI. This essentially takes one of these objects and renders it using the norm. So you find the object by its ID. It's so cramped, I'm sorry. Projector. So essentially it just uses the DOM to put an element on the screen. And you notice the type signature. For all E, it takes a game object and returns an effectful computation. And the list of effects that it takes is E and the DOM effect. This is no polymorphism in the effect mode, and essentially it says it's a way of placing together in effect types. Not really important. It returns nothing, unit. Let's see if we can make the ground move. So the game I'm going to try and build is sort of like Robot Unicorn Attack. You've seen it. It's going to have something horse-like running across the ground, and there's going to be things that it needs to collect, like say maybe a coin.
You say horse-like, you need a polygon.
What?
So you say horse-like, you need a polygon.
We'll see. We'll see. So, okay. Now here's the thing. I've got a crush on this language called M, which has a very nice ultra-reactive programming toolkit, which I've been trying to port to Purescript. You might wonder why I didn't just use them if I like this language. There are reasons. For instance, the word monad is never used, so I don't feel as smart using it as Purescript. So it needs a main function. First of all, I should just restart, so I'm sure that I have a connection to the compiler. So it needs a main function. function runs the effect essentially, and I'm going to, when the effect starts the signal, I'm going to explain this in a little more detail later. I'm just going to write it out. Oh, it's editor. I'm sorry. It always stays at the bottom. I don't know why. Sorry, sorry about that. Now, to get the graph moving, I'm going to create stages according to a reactive stream, isn't it really? It's a function of reactive signal. Essentially, a signal out of which a game object comes. And I pass that value every time the game object changes onto a render function. So I'm going to probably need to start by writing the render function. Oh no, sorry, that's render object. That's my foreign thing up there. But I do need a frame rate. That's going to be a signal that produces numbers. Essentially, it's just going to tick every. There's a convenience function for that. It's called every 33 milliseconds. That gets us a decent frame rate. So every 33 milliseconds, this one's going to use a new numeric value, which is just the number of milliseconds. And I need the ground function. This function is going to produce the actual stream of the object. We are going to pass to the render function. So we take frame rate and when you map that. This squiggly arrow, by the way, that's the LM language creator's idea of what looks like a little more readable version of map than the, what was it, less than, $sign greater than of Haskell. I think it's onto something. Slightly more readable. So I'm going to create an anonymous function that takes a numeric value then, and it essentially just returns an object that I'm going to construct for you. The object has an ID, ground. It has no CSS, empty string. I can't do the Haskell style. Make them look like JavaScript. It's got an x coordinate, which is n divided by 33 modulo 64 multiplied by -8. I write at this through science, actually through experimentation. Just take my word for it. Essentially what it does is, because we get a number and that is incrementing at a regular pace, we want to make the graph move sort of to the left. The ground is a very large texture that extends way over that. And so we scroll it continuously to the left, creating the illusion that the ground is actually moving and infinite. And eventually, just before we reach the end of the texture, we reset it. So you get like a smooth infinite motion. I think that was the connection to the compiler. We're going to have to do the trick here. So base x, 28, base y, 384, that's the current position, I think. And it has no velocity. There we go. It has indeed stopped working. So I'm going to try and reload, hope everything doesn't vanish. Can you give me a cursor, please? Oh, there it is. So, oh, look at that. It works, just like that. So this is mostly purely functional. The only things that are effectful here, actually the only thing that's effectful is the render function. Because I've cheated, because actually getting this frame rate signal should probably be effectful, but I'm trying to be user-friendly and that's how I'm playing. let's try and prepare a character on that, shall we? This is my favourite bit. So, I think we should just go with maybe a pony. Which pony should we go for? No opinion? That's a very good choice, because that's the only character I've got right. So, we'll do that. I'm going to create a static object here. Game object, initial pinky, which describes her initial state. Her ID is obviously pinky, and currently no CSS. I've got some fancy CSS for like animations, which we'll do that later. And initial coordinate 0, 0, we should put it on the ground once we add our base offsets. 0 and 276, which I also arrive at 3 sides, meaning trial and error. The X and y both 0. So of course, that means she's not moving, but she's going to look like she's moving because the ground is moving. Did I already use the initial one? Okay. So it's going to be a lot of copying and pasting here, apparently. And I'm going to need to create a string for pinky. I'm just going to call that pinky. Which is going to be a signal of game object. Actually, because I want pinky to be able to jump, I'm going to take a signal of Boolean onto a signal of game object. So I'm going to provide essentially a stream where the state of the spacebar, which is going to be how I make a jump, is true or false. And I create a stream of pinky based on that. So it takes the key stream as input, and I use fold key. This is like the workhorse of the function reactor signal implementation. It essentially lets me modify the value in the signal based on its previous value, unless new input, in this case, from keys. And so I'm going to follow over a function called logic, which I'm going to write. Initial value is going to be initial pinky. Sample on. This is going to be the stream that I'm putting over. It's not going to be keys because I also need the frame rate. So I'm going to sample on frame rate keys, which means that essentially whenever frame rate ticks, we check what the current value of keys is and return a signal to that. So I need to create pinky logic. Pinky logic takes a Boolean. And the game object, this being the Boolean is going to be the current value of keys. The game object is going to be the previous state of pinky in the last frame. And it's going to return a new game object. So it's going to take an argument spacebar and an argument p, which is pinky. And so for now, let's just return the p. Let's see if we can actually make her come up on screen. And to do that, we should just be able to run a signal like this. Except, of course, we need to plug the spacebar into that. So we need up here. I'm so sorry about the scrolling. Spacebar is key pressed 32, that's the spacebar. And so we build a string pinky of space bar, which calls this one, which takes the key string. And then we run it. It's just that now I need to do the copy pasting again. Remind me next time I do this talk, I actually fix this. I always forget how awful it was. Right. There she is. Woo! Okay. Let's see if we can build a physics engine. Useful. It's actually not that hard. So, I'm very much about to build the actually recording on the screen, but I'm going to show you at the end of the next slide has the full game on it. So I'm going to try and make Pinky jump first. So, first of all, the physics engine. Function called gravity. Actually, first we need to apply velocity. That's velocity, game object to game object. This essentially just takes an object and applies the current values of the x and the y to x and y. So, object modified by x is O dot x plus O dot dx, and y is O dot y plus O dot dy, which makes an object moving with its current velocity. And then we need gravity. Object to game object. Gravity of O is O, where the velocity increases regularly by, what's gravity? 0.98, let's go with that. So essentially now, instead of just returning Pinky, let's try and apply these. First, we apply velocity. Actually, we should apply gravity first. And essentially what I'm doing here is I'm taking the gravity and velocity functions, I'm composing them together, creating a new Pinky logic function. Down, like that. Quickly, getting the hang of it, said nothing else. Paste, and save. And save. I got an arrow. Why have I got an arrow? Would you tell me what the arrow was? Thank you. Arrow in declaration, Pinky logic, and unified object with what? I do not have an arrow. I know. The Boolean. Let's just add that to them. So, jump takes the Boolean. That's no problem. I need to have jump at the end. And the game object, and returns the game object where upwards velocity is applied. So, jump P is P where upwards velocity is minus 20, and CSS is jumping. Okay. And then jump space bar. Now jump type, yeah? No. Main declaration jump. You what? The two what?
You got Boolean and game object.
Yeah, that's true. Oh, yeah, sorry. Jump. If true. Thank you. I'm an idiot. Essentially, if you call it with a Boolean true, then do this. If you call it with anything else, then just return. And now, oh. So we are applying gravity, right? But we don't have gravity. Exactly. Just run out of time, but let's see if we can just fix that one first, yeah? Let's make a function solid ground. Game object to game object. is if I should be using pattern matching now. So now I get to show you that statement, if nothing else. If we are on or below the ground, then return an O where you are on the ground and you're not moving and you don't have the jump animation. Else, just return O. And let's compose that in. Ecologic. So we put it here. It's on the ground. And she stays on the ground. Let's see if she jumps. Because I should have implemented that. She jumps! And she has to be back. Something wrong with that. She's up there somewhere. Oh, there she is. So, yes, you need to check whether she's on the ground. However, I'm out of time. So I'm just going to move to the next slide. While we do check that she's on the ground, and also I'm adding a coin object that she catches. Which also didn't have time to show you the implementation. But there she is. So there's coins. So Dogecoin. I always catch Dogecoin. Catch work. I'm going to be rich. Though it's like 0.0001 dollars. So if I keep at it for about a million years, I'm going to be so rich. Yeah. So the coin is implemented in the same way. There's a signal that outputs the game object. But there's a trick because we need to figure out whether Pinky has touched the coin. She narrowly avoided that. So we feed the Pinky stream essentially into the coin. And we just do the intersect function because we have both Pinky's position and the coin's position. That's not something you want to do in a real game engine. But because there are only two objects in this game, it's fairly easy. So I was going to play some more, but okay, I am out of time. And thank you so very much for listening. So this is the point where I normally tell you where to find my slides on the internet. However, they're still in social net, as you may have noticed. I might put them up a bit later. So you can follow me instead.